Now, previously we were looking at classifying triangles by angles and sides, but there's another part of sides you should know about. You may remember having learned this in 6th grade, but it wouldn't have been called the triangle inequality theorem. You would have been looking at the sides of a triangle and how they're related. Now, let's pretend you are training on the football field either for football or band or something else. And you're at one point on the field down here next to the 10-yard line, pretty close really to 15, and you left your water bottle all the way at the 35-yard line. Now, would you, if you wanted to go get that water bottle quickly, kind of go part way and then make a left to get there? Or would you rather take a straight line? This is part of Euclidean geometry. You would most likely take the straight line because that would be the shortest distance. Now look at the shape we made. It's a triangle. If the shortest distance is a straight line, that means that the other two sides of any triangle I make must always be longer than that other side. Otherwise, it'd be shorter for me to go kind of out of the way and then make a turn, but it's not. So this leads us to the triangle inequality theorem, which says if a triangle has sides A, B, and C, then A plus B, two of the sides must be greater than C. Now your book actually will list all the different combinations of this, but the easiest way to do this problem is to make sure that you have your two short sides being added together and your long side on the other side. I'm not saying the others won't work, but where you're going to find validity is whether a triangle is valid or not is when you put the two short sides together. So to test if three sides can make a triangle, first you're going to label A and B as the two shorter sides. Remember, that's the sides we're going to add together. Then you're going to label the longest side as C. Then you substitute into the inequality. Two short sides must be greater than the longest side. If the inequality is true, then it is a valid triangle. If it's false, then you can't make a triangle from those sides. So first of all, what we're going to do is take a look and see if we can determine if this is a valid triangle and then classify it according to its sides. So I'm going to use a triangle inequality. I find it easiest to identify the largest side, the longest side, and that's going to go on the A plus B is greater than C, so it's going to go on the C side of the inequality. So I'm going to say 4 plus 7 is greater than 10. Go ahead and simplify that. So 11 is greater than 10. That's valid, so we can make a triangle with sides of this length. Now, if I were to classify this according to sides, all these sides are different. So it must be a scalene triangle. Now, looking at this next part of the example, I have 40, 50, and 50. And you're probably thinking, Mrs. Overman, none of them are the largest. I have two that are tied. Well, when two are tied, you can go with either one of them because technically they're the same. So I'll just go with the one on the right. So that's going to be my C, and the other two are going to be my A and B. So 40 plus 50 must be greater than 50. I simplify and I get 90 is greater than 50. Well, that's true. So this can make a valid triangle. Since I have two sides with the same measure, that is two sides congruent, then this is definitely an isosceles triangle. In our next set of sides, you see I have 9, 6, and 2. Most of the time, we are not going to be nice. We're not going to put the sides in ascending order. That means from smallest to largest. We'll mix in the large side, and you have to figure out which one that is. A lot of times, it's pretty easy, like here. It's number 9. It's the side 9. So I need to add together my 2 and my 6 and check and see if that's greater than 9. Well, 2 plus 6 is actually 8. 8 is not greater than 9. This is false. So I cannot make a valid triangle. So it's not scaling. It's not even a triangle. In this one, you'll notice I have no numbers. So what can you do here? For lengths, they're always positive. So I'm not worried about negative numbers here. So I have four sides of 4y, 4y, 4y. It doesn't matter which one I pick to be the largest, but I'll just pick the one on the right. So I set up my inequality. The 2 on the left, add them together, must be greater than the 4y that I picked to be my largest side. When I add them, I get 8y is greater than 4y, which is true. This is fine because remember, we have no negative lengths on sides. And since all my sides are the same, they are congruent, this is an equilateral triangle. By the way, a nice thing to know, especially if you speak Spanish, lateral sounds a lot like lados. Or if you play football, you have a lateral pass, which is kind of a sideways pass. So lados in Spanish is side. Equi, you can probably guess, comes from the word equal. So equilateral triangle means equal-sided triangle. Finally, example 2e. Now, we're assuming no negative lengths on sides here. So I can safely assume that 7x is my largest side. So I'm going to substitute the other two, 2x and 3x, as my a and b in my inequality. 2x plus 3x must be greater than 7x. When I simplify, I get 5x is greater than 7x. Well, that doesn't make sense. So we know that this is not a valid triangle. Now, for finding third sides, this can be a little trickier. The best way to approach it is to break it up into two problems. We're going to find a minimum length for the third side and a maximum length for the third side. And we're going to use the inequality a plus b is greater than c to find the range. So first of all, what you're going to do is assume the two sides that you know are the smallest sides and substitute in, and you're going to find the maximum value for that unknown side. Then we're going to assume that the largest side we know is the largest side of our triangle. And we'll put the other short side with the unknown and solve for the unknown there to find the minimum value. So in this example, two sides of a triangle are 6 and 14. What are the possible values for the third side? Well, again, I'm going to assume these are the two shortest sides, so 6 plus 14 has to be more than x. Or 20 has to be more than x. So that would be like my maximum, just under 20. Then I'm going to assume that the 6 is the short side and the 14 is the long side and substitute in there. Solving for x, I say x must be larger than 8. Now to write a range of values, the easiest way to do it is to put the smallest value first. Our minimum is 8. Then put the x in between because it's supposed to be between 8 and 20. And then put the large value, you're probably flipped, 8 and 20. And then put the large value on the right end. So it would be 8 is less than, x is less than 20. That is a nice way to arrange it. Or if you told me the minimum value is more than 8 and the maximum value is less than 20, I could work with that. Now, another thing we learned about are opposite sides and angles. So there's actually a relationship where you can see that the smallest side of a triangle is opposite the smallest angle. See the 5.4 and the 39.8. And the 68.2 and the 7.8, those are both the mediums. And then the 72 and the 8, those are both the largest angles and sides, and they're opposite each other. This is true even when I move the triangle around and adjust the values. So you can see here I've moved it up, it's an isosceles, and then when I have equal angles, the sides opposite are equal. This is an isosceles, so the two sides are congruent. Then we can adjust it. Let's say I go with a larger angle, like 90 degrees. And you can see that the 10.6 is the longest side. It's opposite the 90 degrees, which is currently my largest angle. So smallest angle, opposite smallest side. Largest angle, opposite longest side. So you can see it here. The size of an angle is related to the size of the side opposite the angle. The longest side will be opposite the largest angle, and the shortest side will be opposite the smallest angle. Now, we have part of our answers here, so you'll live. I'm going to tell you right now, this is an acute scaling triangle. Now, how did we get this? Well, first of all, I want to classify this triangle. Now, all I'm telling you is that one angle is 3x, one angle is 4x, and one angle is 5x. What kind of triangle is this? Well, actually, you can probably guess that it's scaling because they're different angles, so the sides have to be different. But let's go ahead and do the math to show it. All three angles must add to 180. So 3x plus 4x plus 5x equals 180. Simplify, and I get 12x equals 180. Divide both sides by 12, and I get x equals 15. Now I'm going to substitute the 15 in to find the different angles. I've got 45 degrees, 60 degrees, and 75 degrees. So I've listed the angles out here, which, by the way, means that my triangle is acute because the largest angle is less than 90 degrees. Then the sides go with the opposite angles. So the 45 degree angle goes with side BC. The 60 degree angle here goes with side AC. And the 75 degree angle goes with side AB. So in ascending order, my segments are BC, AC, and AB. And you can tell that the sides are different, so this is a scalene triangle. So now I'll leave you with a reflection. Why must the sum of two sides of a triangle always be larger than the third side? Remember, think that the shortest distance between 2 points is a straight line. If you're struggling with this, go back to the beginning of this part of the video and the football field, and that might help you out there. Remember that answering this is a portion of your grade. Thank you. Stop recording.